On the night of July 19th, 1952, something rather strange happened on two fronts in North America. At Mount Palomar Observatory in Southern California, a pair of photographic plates were taken about 1 hour apart, one just before 9 p.m. and the other just before 10 p.m. local time. In these plates, one showed a cluster of 3 star-like points, essentially indistinguishable from stars. But in the second plate, the points had abruptly and inexplicably disappeared. Known as transients, these short-lived events hold much promise in the study of astronomy, in that they show events in much shorter timescales than astronomy normally looks at, a known deficiency for many years. What these 3 star-like points represent is an open question, with potential answers ranging from gravitational lensing to short-lived astronomical phenomenon we currently haven't thought of. They do not appear to be plate flaws or contamination, however. Those leave telltale signs not present in this transient. Rather, they do appear to have been there 1 hour and gone the next. Interestingly, it was possible to constrain their distance, which turned out to be less than 2 light years away at maximum and within the orbit of the Earth at minimum. Curiously, on the other side of the country, the time the plates were taken would have been between 1 and 2 a.m. on the East Coast. At the time, one of the most puzzling UFO flaps in history was happening in the Washington, D.C. area, including multiple radar returns and visual sightings from people in several locations. Coincidence perhaps, but all options must be on the table when trying to figure out what that telescope at Mount Palomar imaged that July night in 1952.
You have fallen into Event Horizon with John Michael Gaudier. In today's episode, John is joined by Dr. Beatriz Villarroel. Dr. Villarroel studies astrophysics and astroparticle physics as a Nordic Fellow at Nordica, the Nordic Institute for Theoretical Physics. She has served as the lead on multiple papers using existing survey data to find examples of exceptional astrophysical transients, including looking for physically impossible effects caused by highly advanced technology.
Beatriz Villarroel, welcome back to the program.
Thank you. It's a pleasure to be back.
Now, in our long-running series on transients, you now have a new paper on a newfound transient in a photographic plate taken in 1952 at Palomar with, I assume, the Hale telescope, which at the time, that was the most largest and advanced telescope we'd ever built. It was state-of-the-art. And yet there's this transient there where in one plate you see essentially 3 objects that look like stars, and then a plate an hour later, nothing. They're gone. Tell us about this new paper regarding this particular transient.
This is a new paper that is actually led by my colleague Enrique Solano at the Center of Astrobiology in Madrid. And he has discovered this image where you see 3 very bright and beautiful stars. And they are there in that unique plate, but you cannot see them ever again, not even 1 hour later. And these 3 stars we wanted to find with the largest optical telescope because we thought maybe they just got much fainter. So we used the Gran Telescopio Canarias, which is a 10.4 meter optical telescope. And we looked there, we went very deep and we found nothing. So they really vanished. And they look real. And it seems to be like another case of the so-called multiple transients that we've been seeing before.
Now, you've written previous papers on this where there are other transients. What makes this one, and I actually know the answer to this question, but what makes this one especially compelling?
It's so bright, so beautiful, so star-like. Because with the previous ones, like when the first case we found, they were very faint. We were wondering, okay, maybe it's some kind of plate flaws that have some very unusual, coincidentally star-like shapes. But again, they were quite faint and close to the detection limit. And now you see 3 super beautiful stars that are there and later vanish. And that is the kind of thing that we reacted on.
So what magnitude are we talking about as far as brightness goes?
I think 15 mag, more or less.
Which for that telescope, that's solid. I think what could a telescope like that?
15, 16 mag to be more exact.
Yeah.
But it's solid.
And they all appear to be the same brightness?
More or less, yes. It's a little bit difficult to get the exact magnitudes of the two ones that are in the crowded region because they are like overlapping. But they seem to have the same, more or less the same brightness, all three of them. Maybe the one in the back is slightly fainter also, but yes.
What strikes me about this is that does not look like a plate flaw. That looks like stellar objects. And that should be there set in stone, so to speak. But that's not what this is, right?
Exactly, because when you have something very faint, you can always try to say that it's a plate flaw, and then suddenly you have these three like super clear stars, and they don't look like plate flaws. But of course, we will always find someone who is going to say, but it probably is a plate flaw. And I think that is why we need to confirm this phenomenon with entirely different methods that have nothing to do with photographic plates. But yeah, they look very authentic.
Now, in your work, you look at photographic plates, and I'm sure you see plate flaws and the characteristics of them. So what does a plate flaw actually look like usually?
No, but plate flaws usually looks like random shapes, lots of random shapes. So in order to get to look like stars, you would need to have a very specific, it would have to, a lot of different factors would have to align up, if we say like that, to make it look like a real star. So I think it's a very, very improbable event. And now to find several of them that look like stars is even more improbable. So that's the thing. And I would also expect that if you have, let's say, 10 very bright plate flaws in one plate, you would see some things that are a mix of different forms, but not that it would only look exactly like the stars in the field. So I don't know if this rant made it clearer.
It did. Now, what about exposure time? In other words, how long was the shutter open on the plate that shows the transient? How long was the shutter open to, sort of eliminate any movement that might be there? Because they appear to be point-like.
50 minutes.
Yeah.
It's a 50 minutes exposure time. So if something would be moving in and out of the image, it should be leaving an elongated streak. It's not going to be, let's say it moves fast. If it moves fast during this 15 minutes, so fast that it can go out of the plate and move somewhere else, you're going to have a streak, not a point source. Now, if it moves very, very slowly, then so slowly that it leaves a point source in the red image, you would also see a point source in the blue image that is taken 1 hour later. But you don't see that. What you see is really a point source only in one image and nothing in the other. So how does that happen? That is the question.
Yeah, you have to wonder that, stars don't just disappear. They don't blink out, or well, at least as far as we know. Hopefully, well, what about things like a really, really weird event, like a gravitational lensing effect? In other words, a naked black hole passes by lenses some normally very dim stars that are out of the reach of the telescope, and you see them very briefly. What about natural, weird things like that with especially gravitational lensing?
So we've been thinking about it for this particular case, because imagine if you have this gravitational lens that is very, very massive, and suddenly behind this lens you would have a short transient, something that flared up just for a few minutes. Maybe what you would see as an observer would actually be that you would see this transient through the gravitational lens, and it would give multiple images. This is one of the thoughts we were having. My colleagues estimated what would be the possible mass of the lens, and they concluded something like 10 times the Milky Way mass. 10 times the mass of the Milky Way black hole. And I'm not sure. We are not gravitational lensing experts, and I don't know if this is a reasonable or not reasonable scenario.
It has to be said, though, looking at the image, it does look like an Einstein cross, you would expect. But at the same time, when you see those, it's usually the entire mass of a galaxy bending that light and making that effect when you see it with like a quasar or something like that. And it would seem to me that, that's an implausibly huge black hole to be not at the center of a galaxy. But it's you have to look at all angles and see what might be there. Now, what about other options with this? What other ideas have you guys come up with that might explain this?
Well, I still think that there is an option of that we are seeing something, either some reflecting the sunlight, or that you see something with its own intrinsic light that is fairly close to Earth, why you see it like happening at the same time. Because, the speed of light is limited, so it's not going to come from a galaxy far away, but it's likely to come from inside the solar system.
Though you gotta wonder though, if it were like an asteroid or something like that had varying albedo and you just happen to catch it, but how did it happen that it had 3 lobes? It just seems...
No asteroids. Well, I'm thinking more about maybe something artificial, possibly, as a possible hypothesis. Something with either, again, its own intrinsic lights or lamps or something, or maybe something reflecting the sunlight, and let's say something very flat, very like glass or metal or so.
There is an elephant in the room. This plate is from July 19th, 1952, which is the evening that a massive UFO flap happened over Washington, D.C. that was caught by multiple radars.
It's quite fun, a coincidence, right?
It's quite the coincidence, and it has to be said that did happen. And maybe I would dare say, though, if that's what this is, a photographic plate from the Hale telescope at Mount Palomar Observatory would constitute probably the best UFO photograph ever taken, right?
There is something even more fun about this. When I discovered, or actually I didn't discover it, when my friend Dave Altman pointed out this date, because it was he who recognized the date when I mentioned like 19th of July 1952. After he had pointed it out, I was wondering, hey, what about the dates of my other candidates? And I went to this paper where we had been looking for alignments. It's a paper called like, is there a background population of like high-albedo objects? I don't remember the exact title, but last year we put it on Archive, and it's a paper that has issues getting published, because it's a little bit too transparent, I would say, about the alien angle. And we had 5 candidates, where there were 2 that were statistically significant and 1 that was the best of all. And in the one that was best of all, you could see 5 objects in a line. And it was called Candidate 5. And if you look at that one, that is from the 28th of July, 1952, which is like also inside this time region of the Washington flap. It's 1 day after the second weekend, I think. I think the second weekend was 26th to 27th of July, and this one happened on the 28th, and I found it super funny. I like that kind of funny coincidences.
We have to remember, too, that this is before satellites. So this is before Sputnik. So we had nothing up there. And I mean, at that time, 1952, we were still experimenting with captured V2 rockets and things like that, and developing further rockets. And we just didn't have the technology to put something out there that would explain this as human interference, so to speak, right?
But what if there were some secret military experiment that resulted in the Washington flyover, but also resulted in that they created some kind of very radioactive particles that were just captured on the plates those nights?
Oh, that's interesting. So there might have been a secret nuclear test that might have done it, that we could do, because remember, obviously, World War II and Trinity testing, and that maybe there was something thrown into the atmosphere that was... But couldn't you look at other photographic surveys and look for the same thing, reoccurring?
Maybe we could actually look for the photographic surveys that are from July 1952 and see if we can find more signs of, let's call them UFOs, or any kind of UAPs, or it's a possibility.
Unidentified astronomical object. I'm coining a phrase. Yeah.
It's an interesting coincidence, and of course it has made me wonder even more.
Now, what other photographic surveys from this time period are there? I'm sure the Vatican was doing it with the astrograph that they had. So what other sources of data can you look at?
Maybe the Lick Observatory could be a good... Well, it could work. Unfortunately, the Harvard plates don't seem too accessible. There are photographic plate surveys, I think, from Ukraine, but I don't know if they have the 1952 year.
Now, what's the future? In other words, we've got really ideal seeming survey telescopes coming online soon, probably the biggest being the Vera Rubin Observatory. Are you thinking in terms of searching modern data sets like that when we get it?
Actually, we are going to try to go a little bit ahead and create our own project called Exoprobe, where we are going to create like where we're going to place multiple telescopes. And they are all going to be filtering away human space debris and human satellites. And we're going to search for this kind of multiple transients, but also search deliberately for signatures of ET probes or unidentified objects that are leaving short transients. We're going to really focus on transients in these searches. And the goal will be like if you use multiple telescopes, then if you see some very short flash in several of them, you directly know that it is a real observation and not something on the plate. Or sorry, not something just in one image. I'm still saying plate.
Independent telescope corroboration of a transient would be amazing.
That's exactly what we want to achieve. And then at the same time, if you use like, let's say at least 2 telescopes, you can triangulate and you will directly say like it's at this and that distance. And now if you use 10 telescopes, you will get a very accurate distance because you can get the location, the 3D location much more accurately if you have many more combinations of triangulating.
Within the question of technosignatures, there is a known bias, and Dr. Sean Kirkpatrick recently stated it as the orbit of Mars. A technosignature outside of that can be talked about like a von Neumann probe or something like that at Jupiter. But when you start talking about anything getting close to Earth, the biases come in, even though it's virtually identical. There's no difference between a von Neumann probe in orbit of Saturn or one in Earth's atmosphere. What's your view on the stigma and how can we sort of try to get past it?
Well, actually, I find it pretty fascinating that there is such a stigma to search near the Earth, because technically, why wouldn't a probe that can make it into the solar system make it also inside the atmosphere?
There's no difference.
There's no difference. So this is just like some kind of social barrier or so. And I think the only way how we can get past that is by doing these searches and show that, okay, we know there's a social barrier and we know that it's going to be difficult to publish the papers, but we'll still look. And even if we don't publish them right now, we will probably get them published in a few years when the stigma is off and people will be kind of much more open-minded. Simply go on and do your best. That's all what one can do.
The other thing is that, you have to ask another question when analyzing this sort of thing, is that, again, we've talked about von Neumann probes and we've talked about Benford probes and Bracewell probes and all this sort of stuff that could be in the solar system, artifacts on the moon or whatever. Yeah. But we ignore the fact that we might be living on the most interesting planet in this star system.
Yeah, why wouldn't they send it right to the Earth? And I think this is the best place to send any probe to. So if I would be aliens and I would know that there's an advanced civilization here, I would send all the probes here and I wouldn't send it somewhere else.
The universe is full of gas giants and Venuses and Marses and things like that, but not so much with civilizations as far as we can tell in SETI. And that it seems to me that bias, the Mars orbit bias, is just really unhelpful because the Earth's atmosphere is where you would expect to find a technosignature, if there is indeed an alien civilization here studying us.
Exactly, and this is where you could imagine that you would see things like artifacts and remains on the planet, maybe in geological records even or so. So I think it's a completely valid way of starting SETI searches here, and simply assume that if we can send something to a different stellar system, also can another civilization send something to us and to the Earth. So I'm totally in favor of this type of SETI.
I also am attracted to the idea of searching the surface of the moon for any evidence of a past visitation, just because the moon, unlike the Earth, the moon does not recycle its surface constantly. And I think that that's kind of a wide open area for technosignature searches, is to start looking at lunar maps and things like that might reveal something that was once there.
I think that's a really, really beautiful idea. And I think there are even some searches, like AI-driven searches for artifacts on the moon, led by ETH researchers in Switzerland. By the way, I apologize in case you hear weird sounds from my end. It's my cat coming here and licking my plate that had some ham on. So sorry for the weird sounds from my end.
Oh, it's quite okay. We like the cat. I like cats, and One of the reasons why I have a separate Event Horizon studio from my house is that my cats will try to talk into the microphone.
And this one might try to. It's a non-human intelligence that is trying to find her way of maximizing her resources. So
Yes, a von Neumann cat.
exactly. Well, I completely agree with you on your entire assessment, both about the moon and about the Earth, and I hope there will be more SETI in that direction, because we have been doing 60 years of radio searches over and over again, always pushing the limit. But if you do something over and over and over again and you don't get any results, it's maybe time to open new doors, because new doors will always lead to something unexpected, even if it's not what you were looking for.
Well, if you're going to look in radio, then it only makes sense, and this has been something that's been changing recently, is if you're going to look in radio, look everywhere. Look at every possible technosignature you can think of and see if it might be there or it might not be. And that's one thing that I think there's not enough work done on is sort of the candidates like Jabilsky's star or HD 139139, where we don't exactly know what it is, but as soon as it looks weird and potentially alien, all work on it stops. And I think that now is the time to change that and take a fresh look at these weird potential technosignatures.
I agree. I think there's an experience that a lot of astronomers have at some point, which is like the driving force. Let's say you're young and you discover some anomaly, and you get super excited, like this coolest thing ever, this anomaly, and you invest months into exploring it, and then in the end you discover that this was something super mundane. And then maybe again some time passes and the same thing happens. And I think what happens is that lots of astronomers develop some kind of, over time, some type of experience of that when it's an anomaly, 95% of the time it's something mundane. And since they want to publish and make good careers and do serious science in quotation mark, it means that anomalies very often get overlooked because people assume that, yeah, it's going to be 90% probability of that this is something boring and uninteresting or instrumental, and 10% probability that this is something real. I better take a more safe road and I go for more safe science. And in that way, a lot of anomalies remain unsolved. While I think the most fun thing is actually to explore anomalies. If we don't do that and stay on the safe side, sure, we can learn a lot, but it's not going to be as intriguing and as adventurous as the more risky road.
It's a high payoff, though, because if you discover an alien civilization, you've just made probably the biggest scientific discovery in the history of humanity, that we are not alone.
But what if there's something even crazier than an alien civilization? Something even crazier to be discovered that you cannot really imagine right now, but you would discover it and it would make the alien civilization look like a mundane explanation.
None of the above. In other words, yeah, that it's something, but it's not an alien, but it isn't from here. Well, that requires paradigm changes, but paradigm changes are common in human history. And for example, someone in the medieval world had no idea quantum mechanics existed. And maybe this works like that we just have no conception of what might be there, and it might be weirder than aliens in the end.
Yeah, and I think there is some kind of idea that I see in a lot of my fellow colleagues, and that is something like that. We have already discovered all the important physics. There's nothing big and new to be discovered, which I find super weird. The first question that hits my mind is, okay, so if you don't think that anything new can be discovered, then what's the point of doing all this research? Well, of course, they will reply that they want to understand the natural processes and into a finer detail and so on, but I find it so hard to, for me, it's a point of view that is very different from my own, because if you look at physics, most has been done in the last 200 years. And what is 200 years in the history of humanity? It's a short time period. And now imagine you have some civilization that has been there for 1 million years. I think they will know so much more about physics than we ever, or that we will do at this point, that I think there's an immense world of discoveries ahead of us, ahead of the humans, and it would be so cool to be part of that and see some of it.
The thing is, though, is that the universe throws curveballs, and we see hints right now of a fifth force, and things like that, and maybe another planet in the solar system, Planet 9. We see all these indicators and things that change our paradigm, and we need to be prepared for that. But in defense of science, most scientists I've known actually really get intrigued when there are discrepancies, hints of new physics and things like that. So at least there still is an open debate. It's not a dogma. It hasn't descended completely into a dogma yet.
I think so too. You're right. Maybe I was thinking a little bit too dark, and I just remember a couple of conversations sometimes that stuck in my mind. You're right. Many scientists are very excited when there's some new anomaly.
But
I remember people were super excited when there was this neutrinos traveling faster than the speed of light at CERN.
I remember that. Yeah, I remember that. And it turned out to be a bad cable or something. But
that's yet another example of when anomalies turn out to have some very mundane explanation.
It's true that you can have, misinterpretation and knowing that your data may be flawed. And, there's all kinds of things you got to go through the whole list to make sure that, confirmation bias, all of these things to make sure that what you're seeing is real. But that's what peer review is for.
Exactly.
So what's the future look like on looking at photographic plates from the past versus looking at new data, new data sets from telescopes like the LSST Vera Rubin Observatory that's going to come online? Can you use computers and things like that to automatically look for these kinds of transients and see if they're still occurring?
Actually, that's exactly what we want to do, but we want to build our own system to look for these kind of transients because we think that they are quite short from what we've seen with these plates that you can only see them in one plate. So what we want to do is to create a system where you have multiple telescopes, where you search for short flashes and you only retain the flashes that are seen in at least 2 telescopes to make sure that they are authentic. And when you have multiple telescopes, you can also, let's say you have 2 telescopes, you can measure the parallax to an object inside the solar system. Let's say that this flash comes from something that is blinking or having some laser. By seeing the flash in 2 telescopes, you will, once you have the parallax, you can get the distance. And now let's say you have 10 of these telescopes and you see the same flash in all 10 of them, then you're going to have a very good accuracy on the distance to that object. At the same time as you are validating the flash and you know that it's real, at the same time as you get the 3D location, you can actually also use a so-called wedge prism in order to measure, get a spectrum in low resolution of all the objects in that field. That is what we are going to do, try to get the real-time spectrum.
When you get a spectra on a transient like this, say you catch one and you catch it in multiple telescopes, so you know it's really there. It's not a plate flaw or anything like that. It's really there. And you get a spectra on it. What happens if that spectra is not that of a star?
Well, it depends on what we actually see, because maybe what we are seeing is some kind of communication laser that looks the same as what humans use in their communication satellites. Maybe also the object that we are seeing is in geosynchronous orbit and moves just like a human satellite and shoots a laser just like a human satellite, and there is nothing that indicates any kind of anomaly. Then it's not super exciting. But what if that spectrum, what if you know that object is something that is very close to the Earth? It moves, let's say again, at the geosynchronous orbit, but what you see is not any laser and it's some very peculiar type of emission that you've never seen. That would be super cool.
Now, how would you go about the process of elimination to begin to ask? In other words, if it's a technosignature, then it could have a signature that is, there's no way that can be natural, right?
Yeah.
And so you say, like with a star, when you see a star spectrum, you see all the absorption lines and all this stuff. And if you don't see that, I mean, it would seem to me to be a very fruitful method of SETI to start looking at these transients and try to catch spectra.
Well, we have our methods that I cannot reveal yet in the ExoPro program, where we'll be removing all the human objects like space debris and satellites. And we also are working on establishing a protocol where we remove the remaining unknown objects. So, of course, there's always a chance that you find some very anomalous thing that is some very secret experiment that some country on Earth has sent there. But I think we know the boundaries of what humans can create and produce, and we will have to check whether the anomalies are within them or outside them.
Yeah, that's going to be a problem because that's a thing in satellite technology, is blinding other satellites, meaning you're emitting some kind of light to throw off the rival satellites and things like that. Now, what about, will this research result in other discoveries? In other words, might you find, when you're looking for your transients and taking plates with this many telescopes, might you find something like, I don't know, Kuiper Belt objects or Planet 9, something like that? Could you catch that with this survey?
I think there's a very good possibility that you can find some very unusual astronomical phenomena that are just happening on these short timescales, because in the timescales we are focusing on, very few astronomers have examined it. And that's what makes it so exciting. And that's why it's so fun for us to explore it. And by the way, just a small thing I was thinking about in connection to the previous question. One more thing, by the way, in the way how we can separate between human objects, even the secret ones, and the non-human objects that we are interested in, the artificial, let's call it ET probes, is that we are going to actually search quite far away from the Earth for starters. Because in that way, we get rid of all these satellites at low Earth orbit, and we get rid of the whole belt of human space debris. So it's a very good thing to try to start and the searches further out, because there, everything that has been, or most of the stuff that humans have sent, are very well known.
So in other words, we know what the signatures of human technology are, and we should be able to tell that from alien technology. For example, if you were seeing, say, the light from some kind of a photon drive or something like that, it would be so characteristically weird that it can't be something that humans produce, right?
Exactly. Exactly. So that's how I'm imagining that you can identify some of the unidentified objects. Or if you find, let's say, something that maybe looks more like a conventional ET probe, but in completely wrong place. No country says that they have sent their space rockets, and it's too far out to just be a random object that is there that nobody knows what it is. That's also a possibility.
Now, you can use parallax to determine that distance, right?
Of course.
When you're using multiple telescopes, and you can determine that this is either close or far away.
Exactly. And that's what we want to do.
So where are the telescopes going to be located? I mean, is it globally, or what telescope locations are we looking at?
So actually, we hope to get it globally. But in the first phase, it's going to be in California. So we are looking to put up a telescope there in Sierra Remote, and also 2 more locations. So that's where we are now. We are trying to solve the administrative things with the telescopes.
What kind of telescope apertures are we looking at? What are the size of these telescopes? It would seem to me you could do this with very small instruments, right?
Exactly. We are going to go for very professional, state-of-the-art half-meter telescopes that have super good tracking and very good mounts that are reliable to do this type of work. And yes, they are pretty expensive. So of course we have to work on that end to make it happen. But these, we're imagining at least 3 telescopes in California, and hopefully within the near future. So one is being ordered, and there are 2 more not equally good as the one that we're ordering, and one that also one of them actually recently had an accident, so we need to solve that too. Yeah, there was a little accident that happened with one of them, and we will need to replace it.
Now, this also seems like something that citizen scientists might be able to do, look for transients, because there are a lot of people doing astrophotography out there, and there have been for decades, and that maybe people that have archives should look and see if anything's missing in their photographic plates that they have, and let you guys know about it.
I would love if they did that. And we also have a citizen science project that we've been running with the VASCO team, where people can go and actually search for this type of objects that are vanishing. We're now actually wrapping up the results from there. And we found some thousands transients. We didn't find any example of a star that is there in 5 places and later vanished, but we found many of these short-lived transient things. So everyone are welcome to help us with it also. Or they can also do it with their own telescopes and their own archives. I think there's a lot of potential when it comes to transient searches, especially in the short time region.
Now, you recently spoke at the Seoul conference, which was put on by Gary Nolan, and regarding the UAP. Tell us about that.
Oh my God, that was the most interesting conference I've been to probably in my life. So fun, so nice people, so brilliant thinkers and minds, and like such a diversity in the type of work people are doing. And still there is such a unity because everyone wants to understand the phenomenon or the UAPs, or if there are ET probes, and this curiosity people had, like there was such a passion for the topic. Apologies for the sound background.
That, just for the listeners, that is the sound of a very active cat.
Yes.
All right, Doctor, thank you for visiting with us yet again. And I look forward to the next paper because I'm just fascinated by these transients. And legitimately, this is one of the things that really puzzles me these days in science is these transients, especially this one with the Palomar plate, because it just does not look like, it looks like stars.
Yeah, that's the thing. It's like we have several of these cases with the multiple transients, all look like stars, and some are even aligned, like lying beautifully in a line, like if it was satellites moving and tumbling. And of course, they are from the early 50s when there was nothing human at those high altitudes or in space. So I find it super puzzling. And maybe there's some new physics that I don't know about. Maybe there's some completely different type of explanation. I'm, of course, also limited with my bias, but I find it fascinating and I want to understand more what it is with new projects and everything I can do to solve the riddle.
Natural or artificial, it's going to be interesting.
I think so too. I'm very curious about where it will lead.
Early in the morning or late at night, whenever you like to watch Event Horizon, there are more relaxing and mind-bending content to follow.
Beatriz Villarroel, welcome back to the program.
Thank you.
Now, Doctor, you are working on a new project, an extension of your work with detecting transients. But let's go to the transients first. Looking at old photographic plates, pre-space age, and seeing if there's anything there that looks like a satellite. Where is that work today? How many candidates do you have, and what's weird about them?
So what happened was that in 2021, we found an image where we had 9 stars, or star-like objects that were there in one image, but they were not there half an hour earlier nor later. So it wasn't stars, of course, it was transients, something that appeared and flashed out of the image within half an hour. And the weird thing is that it was 9 of them, not 1, and it was in a small region of the space. So one possibility that we were thinking of is that this might be something that shouldn't be in the sky in that time. For example, maybe these were caused by some kind of solar reflections of something artificial. However, the problem was that these images were from 1950, 7 years before Sputnik 1. So what we did is that we wrote a new paper on how can we test this? Well, you can test this if you also look for like multiple transients that are aligned along a line. And we did that work. Then we searched for these candidates and we actually found a few such examples. We wrote a paper, submitted it, and that paper has a hard time in the review process. I think there is stress among the referees. Plus, there's something that has already happened to me more than once, is that there are a number of astronomers that missed the fact that there were no human satellites in 1950.
No, it was 1957, as I recall. Sputnik was the first.
Yes, exactly.
So now let me ask you this. All right, so taking this at face value and that it's not a measurement problem, the photographic plate didn't have any dust on it or anything like that, that you've basically eliminated at this point. The question is, all right, we seem to have a window of where we could look at these again before our skies are filled with Starlink and other constellations of internet providing satellites. So we need to look quickly to try to reacquire these if they're still there, right?
Exactly, because like in the coming decade, they're going to launch another 100,000 objects. And how are we going to find anything alien up there after that we launch all these objects? It's going to be impossible. So we need to do searches as soon as we can, I would say.
Can you build an algorithm that would look at unusually behaving satellites? In other words, all right, Starlink satellite is going to be going in a straight line at a certain speed, but if you start seeing things moving around unnaturally, like they shouldn't be, which is a hallmark of the UAP phenomenon, if these are indeed that, could you do it that way and search using algorithms, artificially intelligent algorithms?
Well, I think it is a possibility. The question is not if one can do something, because I think one can usually try all kind of methods, but it is how efficient is it to do it that way? And how many false alarms do we get if we follow a particular route? And I think the great challenge is to find a way of inspecting as a big volume of data as possible without getting stuck with thousands or millions types of false alarms.
Are there other data sets you could search for transients from that period with photographic plates? I mean, could you go and perhaps look through someone else's data set with the Vatican or something like that?
Well, there are such data sets. However, there is one problem when one looks for UAPs or probes in the old data sets, and that is that you usually only see them on one image, so you cannot really say or predict where they are today. So you know that maybe they were there 70 years ago, and you will confirm, yeah, there was maybe something interesting 70 years ago, but how will you find it today, and how will you confirm it with modern data?
So it's sparse, ultimately.
Well, it's not going to bring a UAP to your hands, which I think is the ultimate goal.
Isn't that the problem, though, perpetually with that issue? Because you're talking about, when you talk about somebody that saw something interesting and reported it 70 years ago and they're gone, you can't question them any further. So you just have this report.
Exactly.
And in this case, you have just one image showing something that really shouldn't be there. But today we have much better technology. So what would an ideal system look like, in your view, to search for these things in a modern context?
So this is a tricky question, because I'm actually going to say that our new system, Exoprobe, is an ideal such system. But I cannot describe it in detail because we are still with a proprietary design. But I think the important thing is that no matter how we construct the system, you need to validate and verify your finding as soon as you can, and you need to be able to localize and relocalize the probe if you find it. That is how I see these features needs to be in any system.
Can you do that in-house? In other words, can you build several separate independent functioning instrument packages to self-verify it without having to, contact another institution that may or may not have suitable equipment to pick it up?
Exactly. That's a very good way of doing it.
So where would you place such an instrument package? Now, people are going to ask me, well, there are UFO hotspots. So is that where you pay attention to the accounts?
No, not at all. I would only pay attention to, first, if I'm going to look for UFOs, I'm not going to care about the things that move inside the atmosphere, because I don't want to deal with millions of false positives from birds and flies and, flying ducks and airplanes. I don't want to be dealing with all that. So I would only care about things outside the atmosphere. That's the thing I'm interested in.
One very quickly would get sick and tired of looking at flying geese if you didn't have. Now, let me ask you this. The Vera Rubin Observatory that's going to come online with the LSST, this is giving us all-sky surveys. So if you're looking for objects that are outside the atmosphere, cooking through the solar system at large, do you see this data set that's going to be coming after first light as a very important thing that you could look through in order to try to determine if there's something in the solar system itself?
I think that it's going to be extremely valuable, and one will be able to do that. However, I still think we are going to be challenged with lots of space debris and things that look like fast flashes that come from all these space debris and satellites. And I'm not sure that Vera Rubin will be the optimal way of looking for probes in particular. But I'm sure that one will learn extremely much about the universe with it. And maybe even find ET in some other way with help of it.
Well, and the other idea, of course, with that is that it will pick up interstellar objects like Oumuamua, which could be candidates for some sort of technosignature passing through the solar system. So there's that value. Now, radar. So say you see a transient that's weird in a modern context with modern equipment. You see a transient. Of what use might radar be? And methods of basically clandestine methods of lighting up spy satellites and looking at that sort of thing. Do we have the technology to go further than just a visual sighting?
Well, I don't think we even need a radar, because if we use the methods that we are working with this exoprobe, we can probably localize it pretty accurately if we manage to set up the entire network as we want, and we will get spectra. So I don't think we're going to need the radar, really.
Do you think that we have enough at this point technologically to
Absolutely. We have everything.
But to take the question further, so we see an unidentified orbiting object, right? Yeah. We won't call it flying because it's not in the atmosphere. An unidentified orbiting object.
Yes.
Do we have any hope of determining its origin and identifying it? In other words, we see something. Well, what do we do to determine if it's of alien origin?
There's a lot of things one can do. We have some ideas that, again, are a part of the proprietary design, so I unfortunately cannot say them. But there's quite a lot of simple analysis one can do. And ultimately, I think the best thing would be to, once you have localized it, to go and fetch it and bring it down to the Earth if you want to study it really well.
As long as it allows you to do so.
Well, I can always try.
You can always try, but if the orbiting UAP says no, that would actually tell you more than actually capturing it, because it would tell you that it's clearly of intelligent origin from somewhere.
Well, maybe you can flash with a communication laser on it and see how it reacts and try to communicate with it.
Hey, that's an old idea. That was let's see, I think the Bracewell probe was the idea, where you do something to communicate with it, and that's the only time it communicates back. It returns your signal to you. And it's just basically a mirror, but that tells you enough, right?
Or if it's like a cat, once you communicate to it, it just vanishes and leaves the solar system. And that was the end of your study. So,
or it gets very needy and then it starts wanting things from you. It's like, give me more solar energy collectors. And all it does is keep asking for raw materials. So tell us more about your new project as far as really getting into this and looking for the phenomenon in this way. And again, I want to make a distinction here, not atmospheric like UFOs, but out in space.
So the basic is that we plan a network of telescopes to search for solar reflections or lasers of an ET probe. So it's we are looking for the same signatures as we did with the photographic plate survey, but we use this network of telescopes instead. And the point is that we want to have an instant validation of every transient we find, and we want to get this very accurate 3D location of an eventual probe if we find it. And then the big work comes in the actual techniques that we need to employ in order to distinguish anything that is human-made from anything that is alien, which is a long series of filters.
A long series of filters, what does that look like? I guess it's just algorithms and computer stuff, essentially?
Essentially, yes.
Now, what happens, all right, say you get this going, and what happens if you make an unambiguous detection and you have to go to the scientific community and say, hey, there's something here? Do you anticipate any problems with that? I mean, can you get the rest of the scientific community to pay attention if you find a signal among the noise?
I think first it's going to take probably a couple of years while people are ignoring the result. I think that's unavoidable because people will always assume that if you get something positive, it has to be wrong. But at the same time, that could give us some time. Actually, the skepticism could act in our favor, because if people don't believe us, we might have enough of time to, I don't know, maybe organize a space mission to fetch it. So that's how I'm thinking. It's not always so bad if people don't believe one from the beginning.
The scientific payoff, all right, if you were to discover evidence of alien life, even if it's close, which SETI has always assumed that it wouldn't be, and that we're looking for distant radio signals, but not too distant. I mean, they search nearby star systems more than they do anything else. Do you anticipate that by discovering it, and we'll hypothetically say that it's there. Okay. And you discover it. The accolades. Do you think there is a Nobel Prize in this? And
absolutely not.
And really. So the discovery of alien life, which would fire the public imagination above anything else probably, would not win academic accolades, at least initially.
I think it wouldn't win academic accolades at all, because if an astronomer will go in and confirm, yes, the unidentified objects are actually alien spaceships, then you will have 1 million of people who said, hey, I took a picture of it before you. Look at this photo. You never believed me. So who is going to be the actual number one discoverer?
Well, that begs a question. Wouldn't it be the photographic plates from 1950 as the first?
I think it will be every person who claimed to have photographed a UAP.
True. So, of course, 1950 is very early. I don't know. I guess the first, the UFO phenomenon entered the public consciousness around 1947. So I don't know that there are earlier photographs, but it would be the first scientifically actionable photograph, right?
I don't know. I am unfortunately not aware of any photographs from earlier than 47. Or do you mean things that scientists have published?
They do go back earlier than that. I mean, there are photographic surveys from the 1890s, as I recall. If you found something in there, that would be really strange. But I don't know what accessibility is like for photographic plates. How is that? How does that work? I mean, if you go in and say, I'm looking for transients in old photographic plates, can I see your past photographic plates? Do you get blowback just from phrasing it that way?
Well, I think if one asks what has happened is that people say, okay, we treat it like gold. Not anyone can come here and watch them. So there is that attitude, because these are really, really extremely valuable plates. So they are usually closed in a vault. Well, only certain people can go there and look at them.
I see. So there's a gatekeeper on a lot of this stuff.
Exactly, and that's why I think it's so important to move on to the modern data, which is why we started this exoprobe. Because it's frustrating to be stuck when you cannot examine these things and you cannot proceed in that direction. So then you have to create your own path to solve the same problem.
All sky SETI surveys, all right? We're starting to talk about that, where you look at the entire sky instead of a targeted SETI search.
Yeah.
Do these seem to possibly be of help, or are they going to just knock out these transients as noise?
I think they are really, really exciting, all sky SETI projects. I think Laser SETI is doing an amazing work. And then there are the other projects that are maybe not all sky, but still see quite a lot of the sky, like PanoSETI, Galileo project, Sky 360. And I think these projects have a very big potential to succeed. I'm very optimistic. Let's see what happens when they have been running them for maybe 5 years or so.
Yeah, it's interesting, but they probably wouldn't be of help with what you're doing looking for closer transients, right?
Yeah, it's a completely different thing we work with, indeed, because we are really restricting ourselves on looking for transients that come for solar reflections or lasers from objects nearby the Earth. So we are...
That would be... that would be interesting, because if you found a transient like this, right, and you're like, well, what else could it be doing? And you detected laser light from it. that would be unambiguous. And that's the big problem in SETI, is ambiguity, of course, where you look at something that could be of alien origin, but rightfully the scientists usually say, well, we need to look at the natural explanations first and exhaust those. Do you think there's a problem, though, in the search for technosignatures, close, far, whatever, in scientists spotting something and then not following up on it for lack of funding or lack of interest in it, because it could affect their career if they found that it was alien? Do you think that the stigma that follows the UAP phenomenon is that bad?
Yes, I do think so. I am absolutely sure of it, and that it's there is a strong stigma. And what happens is that if you go on with your research and you say, okay, I'm going to do this anyway, and I will fight against the stigma and I will prove my work. Yeah, it can work for a while, but what happens if you are not having a permanent position? You will at some point have to apply for funds. And even if you are ready to face the stigma of the society, maybe the committee who is giving the grants is not going to feel the same way about it, and anyone ends up with a lot of rejections. So I think a lot of interesting results might have been buried under stigma. That's my genuine impression.
Do you think it's changing with the recent attention of the U.S. government?
I'm not sure yet.
I mean, I wonder if they would be open at this point to funding such a search.
I don't know. I guess I will find out when I submit my grant applications. So,
Now, who else do you go to? I mean, okay, so the U.S. might be a possibility, but what are the European Union and ESA and things like that? Do you think there's any hope of funding UAP research in your grain? Or how about France or something like that? Do you think that there's any possibility there?
As far as I know, there has never been like any grant to pure SETI research in Europe. So I don't think this is going to happen too quickly. I think that it needs to first happen in the United States and go on for 5 years or 2 years, and then it will happen in Europe.
That begs a question, though, a geopolitical question, is that could another entity like Russia or China leapfrog and say, we're really going to look into this and make the discovery? You got to wonder, because there are different cultural attitudes, and maybe the taboo is different in other countries as opposed to the West. Do you think that might be the case?
I think so, yes. It's not impossible.
Do you think it's plausible? And this is a question that a lot of people ask. How do aliens cross space-time and get here? Do you think it's plausible that they could be here? And I already know the answer to the question. It is in certain circumstances. But in your view, plausibility of an alien presence in our Earth orbit?
I think it's absolutely plausible, because if you look just in our Milky Way galaxy, you have like 40 billion of Earth-like planets. I mean, 40 billion, that's what we estimate. And now we can send something like Voyager to another stellar system. So why wouldn't they be able to send something to us, a probe or so? So I think, yes, there are very good reasons to believe that there might be lots of probes everywhere.
The Fermi paradox is predicated. Enrico Fermi asked this question: where are they? Do you think that applies equally to near objects of alien origin and far objects of alien origin? In other words, is the strategy that SETI uses looking for distant objects perhaps misguided? Because if you've got just one alien civilization in this galaxy that's been here for 1 billion years, chances are they would be here, right?
Well, actually, you're totally right. I think people have spent a lot of time talking about the Fermi's paradox and where are they, when they should actually be discussing where are they? Are they here? Are they a little bit further away from us in a different system? Or it's the problem with Fermi's paradox is that I think too many SETI scientists have been stuck in the philosophy why we should actually just look and try to localize them. That's my point of view.
So, in other words, it is. Do you think there's a bias here, right, between far objects and near objects? In other words, do you think that by looking for distant radio signals, which are very hard to pick up, I mean, the chances of actually picking up a weak radio signal from 10 light years away, inverse square law stuff, it's just not very likely that we would do it unless it was a big screaming beacon, which was originally what Cocconi and Morrison had proposed in their paper that kicked off SETI, or at least modern radio SETI. Do you think it's actually would be more fruitful to look for these transient objects that might be of alien origin as opposed to a distant radio signal that you probably aren't going to pick up? Because let's be honest, nobody that's looking at Earth is very likely to pick us up as far as our transmissions go unless they are looking right at us with a very giant radio telescope. So do you think it might actually be more fruitful to search the solar system for evidence of alien life?
Absolutely. And actually already in the 60s, they were not only proposing to look in the radio, they said, okay, let's look in the radio, but it would also be a good idea to look for spaceships and so on. However, in the 60s, you didn't have the same technology that you have available today in order to do these searches in a cheap way. So in the 60s, you wouldn't be able to survey the sky and employ a super efficient AI that would look through all the images. All these things as our technology of today. And I think that is why one left that route and went into the radio route. While today we can actually follow up on the probe route. So I think it's simply that radio SETI had its time period. when people did a lot of radio SETI. And now we finally have the technology to actually do, well, searching for probes. So it's time to follow this path.
Multiple detections at the same time in a photographic plate of multiple objects. I think you said 9.
Good.
So these objects appear and then they're not there. And they all appear at the same time. That's really strange, right? In other words, you're not looking at one object, you're looking at multiple objects appearing at the same time. What might that implicate?
Well, there are 2 possible explanations. One is that you have some type of extremely rare plate defects that all coincidentally look like stars, which maybe could be caused by some kind of unreported nuclear bomb tests, if you have nuclear fallout coming to these plates. Or alternatively, you do actually see something real in the sky that nobody has taken note of, because these occurrences are really rare, and if they would happen in the sky today, people would think, oh, it's just satellites or space debris. So these are the 2 main routes one can go.
Oh, that's an interesting question. Space debris. Not just Starlink, but just general space debris is going to confound this the further we go on, right?
Yeah.
I mean, just anything, paint chip or whatever, if you're looking at high enough resolution, is going to confound this search. But at the same time, that stuff moves in a very predictable way in LEO. What I'm interested in is what if you see an object that is clearly violating the laws of physics in orbit? You know, that's always an ever-present.
That would be so beautiful. That would be so exciting.
Now, say you saw that, right?
Mm-hmm.
Let's play around with that idea. How would you publish? And what challenges would you come across publishing?
I think we would publish it the same way as always. One would probably have some issues with the referees not believing it. One would still submit it to a journal. One would maybe put it on archive. And simply go about it the same way as one always has done it.
Do you think that the Galileo project, which you're part of based at Harvard, will face the same problem when they try to publish any findings, even a null finding? When they try to publish, because that's one of the intents of it, is to publish it in credible scientific journals if they find something or don't find something. Do you think they're going to face the same uphill battle in publishing?
I think, yes, everyone are going to have the same problems if they find positive results. I think it's only easy to publish SETI as long as the results are kind of negative or don't have too big implications.
After multiple published papers regarding UAP and taking the subject seriously, do you think that it will then get past the hyperskepticism and blossom into a new field of study in and of itself if there is enough of a signal amongst the noise to prove to scientists that there is something there to study?
I think so, yes. And when one finally would confirm that, yes, they are alien probes and UAPs, then everyone, all scientists would say, but of course we knew that. Of course, this is evident. So I think it would go from hyperskepticism to of course it's evident. That's my guess.
Does the notion, and again, we're just speculating, but does the notion of a close presence of an alien civilization to Earth, as in orbit of it, keep you up at night? Is that a scary thing?
No, that would be very exciting, I think.
Until it fires its giant space laser and returns human civilization to the Stone Age.
Or abducts me.
Well, it has to be said that if there is some sort of a presence in low Earth orbit, they'd have done something by now. We wouldn't be here if their motive was an invasion or something like that. But if you were a scientist 10,000 years in the future and you found an alien civilization around an exoplanet, on a planet around an exoplanet that was in a lesser state of technological development, as a scientist, how would you go about studying that? Say you could go there and you could study that civilization. What would your methods be? Would you just stay relatively quiet and act like the UAP phenomenon seems to do here?
I guess such a civilization probably has a really, really advanced bureaucracy or something that probably forbids them to interact. That would be my guess.
That scares me more than an alien civilization's presence does. A highly advanced, artificially intelligent bureaucracy, just what we need.
To make it as terrible as possible.
But, people make this point. People make this point that, well, we would be ants to a more advanced alien civilization. We wouldn't be of interest. But my thinking has always been, well, if they're scientists, and you're not going to travel space if you don't have science, if they're scientists, you're going to have specialists that would be curious. And it doesn't seem to me to be that far of a stretch to say that somebody long ago was studying exoplanets and they saw Earth, which has been screaming oxygen, unnatural oxygen and methane levels for a very long time, billions of years, or almost 2 billion years. And they saw that, well, that's plenty of time to send a self-repairing, self-replicating von Neumann probe to sit here and watch and just keep tabs on it, and report back. Taking that further, if that von Neumann probe could print out an atmospheric probe and it dips into the atmosphere of Earth occasionally and someone sees it, there's your UFO of alien origin that stays within the laws of physics as we know them. And you could even play with ideas where such a thing could print out aliens, biology, and print that out. So that's the weird thing about the UAP phenomenon is sometimes, not always, but sometimes the really weird cases sort of look like that. And there is a plausible way. It's just that there's a stigma that prevents discussion of it. And I wonder, at what point does the stigma get overwhelmed in your view?
I think there will come a point when scientists have heard, if this is correct, because that's the first assumption we have to make. If we assume that there truly is some kind of ET probes around the Earth, then at some point there will be so much of data gathering and so much of not only that data from scientists, but also testimonies and all the things that collect together that people will say, it's of course like that. And they will just accept it. Maybe one needs to prolongate the discussion so much that people eventually get bored and just agree to it. It's one possibility if one assumes that is the case.
Do you think that we have a sufficient handle on what we know about the universe? We have incomplete physics. Do you think that it's possible that something like this could be even weirder than aliens?
I think it is fully possible, but I would be hesitant to speculate about what. But yes, I think that we are learning about the universe all the time, and every time that we think that we know everything, we learn something even more that is much crazier than we could ever have imagined. And that's how the really big, revolutionary science always has progressed. So maybe there is something much weirder and maybe much scarier than aliens.
If it's not aliens, then it gets into territory that we
don't want to go there.
Yeah, we don't want to go there, but we would be forced to. Now, what happens if you get the opposite and it ends up a complete null result? Does that still answer the question in terms of saying there is not an alien presence here? Can that be pursued to knock it out after you see enough null results? I mean, can it go the opposite way?
Well, it could go in that direction, but it doesn't mean that there is an absence. It just means that, again, no matter the ways how we have been looking, we haven't succeeded in finding anything. And maybe it, of course, would say that maybe we are one of the very few really advanced civilizations, because it's possible that all these Earth-like planets are full of very primitive life or nothing at all. But I don't think we ever can reach a guarantee of being alone in the universe.
Oh, no, you couldn't, because, we try observing outside of the observable universe, and we don't know how far that extends beyond what we can see. So you could never eliminate it. The thing is, though, is that statistically, if we are alone, that's actually worse than the suggestion of the existence of alien life, because then we live on a very, very special planet that's like the island from Lost, where organic chemistry that happens here that happens nowhere else in the entire universe. And all of those stars and galaxies, the myriad of them, are dead but this place is not. And I actually find that to be an even scarier option.
Absolutely. In total agreement with you, it would be terrifying.
Yeah, that's where things like Copernican principles and all that drop off the table. And this is a very unnatural, very special world, especially when you look at it in terms of quantum mechanics and observation and all this stuff. We're the only thing capable of building detectors in the entire universe. And you start to run up against weird stuff like the double slit experiment that it's like, what exactly is going on here? But if you have aliens, or you have a multiverse for that matter, if it becomes more understandable. And I actually hope that we find aliens, or even just a microbe on Europa or something like that in the oceans of Europa, so that we don't have to wonder about that existential question of what it really means to be alone. Do you agree?
Yeah, I totally agree. And I think we will find microbes on other planets, and I think we will succeed with it. It's just that we need to have some patience. I'm an optimist.
And we need funding and missions.
And we need funding, exactly.
Yeah. So you have to convince NASA to start doing life detection missions again for microbes on Mars. And I think a nice aspect of this is at least we have hints of it. The positives, which may have been false positives, but maybe they were real, the Viking experiments or things like that we might actually find that life is more robust than we ever thought it would be on places like Mars, like the radioactive surface of Mars. Or if recent work, which I've done some recent interviews on these topics, of how RNA forms and how the cell membranes form. And it starts to put places like Io on the table, that maybe early on, when it had some water, it might have spawned biology. So I don't know that we have a broad enough view of life based on our sampling of one to predict what life could be like. The question is that if it's really weird life, how do you detect it?
That is a very important question indeed. And I think we might not be ready for some hundreds of years to even answer it. So we probably only would be able to detect life the way as we know it.
Do you think, all right, say you go forward with the work and you detect something, and we go up and we collect it and bring back an alien artifact from low Earth orbit or something like that, geosynchronous orbit or wherever it may be. What do you anticipate the effect on human civilization will be? Do you think everybody will just shrug? Or do you think that it could cause chaos, as has been suggested in the past, social chaos, and that we couldn't handle it?
No, I don't think so. I think humans have a wonderful thing of being able to adapt to new circumstances. What I think it would happen is that if you bring the probe, then suddenly there would turn out that some other agencies have also found some probes, etc. And then there would start to turn up a lot of probes everywhere. And then one would actually, as a humanity, start to collaborate to understand what everyone has found. That would be what I expect.
And do you think that if it turned out weird and would be a blow to the human ego if it turns out they're not here to study us?
They came for the cats.
Like Star Trek, where they came for the cats, and that we're of no consequence. I would actually really like that. That would be amazing if the first detection of an alien civilization is, a message that says, "Shut up, we're studying your cats."
Well, I think that would be a positive thing for humanity.
I think it would be if we were told that we weren't really that important in comparison to iguanas or something like that. We might be able to get along a little bit better.
I think so too. We would have suddenly a much stronger solidarity among ourselves.
Well, I think, as a serious question though, the discovery of an alien civilization, no matter what, is going to have that effect.
I think so too.
Because we are no longer nationalities, we are the humans in that context. And we enter the world of science fiction at that point when we know that we're not alone, even if it's just a distant radio signal, narrowband signal that's unambiguously alien in origin. We suddenly are in a much, much broader context. And I think that could be a positive effect of a detection of an alien civilization, don't you?
I actually only expect positive effects, unless we detect them by that they come to invade us.
Though, again, If that was their motive, they'd have done it.
Exactly.
They wouldn't have waited for us to develop nuclear technology and things like that.
Or they wait for the right moment. It's not impossible that either. You can't know.
True. Yeah, well, that's one thing, is they might be here to keep us from destroying ourselves. And or, they view all life in the universe as precious and rare, so they protect it. And we just haven't done anything yet that's to the level that they would consider to be dangerous. Or they might even be a police force, because they could say, when those humans develop artificial superintelligence that's smarter than they are, we have to intervene. And that it's just simply they're sentinels, just watching to see what we do to make sure we don't develop something that could threaten everyone else in the galaxy. And
or they're just preparing the starter and waiting for the party to begin.
True. That's the other thing what is the nature of an alien civilization? We have no idea. So it could be that when we do discover one, it's a machine, and it could be the collective development of technology of an alien civilization for far longer than we have, and that the end result is everything in the galaxy is machines.
And that would be so depressing. Actually, that is the second scenario that I would find very scary. Not that we are entirely alone, but that we are surrounded by machines, or that is the only thing that survives enough long.
That would be a terrible scenario, because then you got to ask the question, where is its biological progenitors?
Exactly.
And it might tell you, it'd be like, they went obsolete. I don't want that universe.
No, me neither. Then it might be better to be alone in the end.
But at the same time, you could just as easily find that alien civilizations conclude that biology is better, and they just keep it. And we might do the same thing, and we never go through the singularity or anything like that, and we never achieve superintelligence because we wish to remain human and continue as a biological existence. So they might make that choice. In regards to the UAP, though, and Jacques Vallée has made this case that sometimes it looks even weirder than aliens, and I was hinting at that earlier. Do you think, based on an overview of the UAP phenomenon, do you think that it actually looks like what you would expect as a scientist an alien civilization to look like? Is it consistent with that, do you think? Now, I'm not so sure about this.
I cannot answer that question at all, because I am no expert on UAPs. What I can help with is to examine the hypothesis of that the UAPs are some kind of extraterrestrial probes. That is where I can help. If that is something much weirder than aliens, let's say that this is, I don't know, some multidimensional creatures, then I will not be able to do very much for the topic.
Yeah, how would you even measure a multidimensional creature? I mean, how do you start? At least
you would have to ask it the number of dimensions.
You would, yes. And we just don't know anything about that. I mean, we know about our three-dimensional world with the dimension of time, but upper dimensions, all you got really is the variations of string theory of 10 dimensions and all that. But what would that even look like if it somehow could manifest in what we can perceive? It's like Carl Sagan's old Cosmos episode where he was showing the Flatlanders and what they would perceive a three-dimensional creature or object passing through their plane, what that would look like. And we can't even imagine what an upper dimensional object would even look like, right?
Oh, exactly. So I think when it comes to UAPs, I stay with my simple hypothesis that I can help with and to explore.
Now, what would you say to any other scientists thinking, this UAP phenomenon, maybe there's something worth studying there. Maybe we should try to figure this out. But if I do it, my career could end. What advice would you give researchers that are sitting on the sidelines thinking, well, maybe I should go and join the Galileo Project or something like that? What advice would you give them?
We only live once. Do what you are curious about and hope that things work out anyway.
For joining us today, and as your work continues, and hopefully you can get this new project funded, I look forward to talking to you again.
Thank you. It was a pleasure to be here.
We live in a world where we are constantly observing ourselves from orbit. We don't even think twice about the satellite surveillance of our world because it's us doing it. But imagine if we were being watched by someone else, far before the dawn of the space age by some unknown agent. More, think of a scenario where it was watching us, and we were inadvertently with our astronomical photographic plates watching it as well. In 1957, the Soviet Union launched humanity's first orbital satellite, Sputnik 1, ushering in the age of telecommunications and satellites of all flavor from weather to espionage. But our ability to monitor the skies photographically stretches decades before the advent of human space travel, leaving us with an enormous collection of astronomical survey plates to study. Within these plates, previous to 1957, you shouldn't expect to find anything transient presenting itself as a satellite since we didn't yet have them. But that's apparently not the case. In a photographic plate dating from 1950, my guest today has identified a transient phenomenon that not only appears like a satellite would, but actually tracks across the plate exactly as you would expect a satellite in orbit of Earth would do. Now, there have been conspiracy theories floating around on the internet, such as the Black Knight regarding satellites previous to the space age. But these are urban legends that conflate different sources, usually coupled with a photograph of a very human-made thermal blanket in orbit. But there is a kernel of something here. There was one such mention of the possibility of artificial satellites of unknown origin before the space age began, that was made by Major Donald Keyhoe, a prominent figure in the early days of ufology, reporting that the US government was aware of 2 such satellites. If there was any truth to that report is unknown, but it's interesting nonetheless. Adding to this mystery, there are obscure oddities hidden within the history of science that may deepen this mystery. One of these are the mysterious signals Nikola Tesla reported picking up that he thought were of alien origin, though in reality it could just as easily have been pulsars or any of the other myriad of natural radio sources that were unknown in his day. But there's also the case of the long-delayed echoes in radio, where transmissions repeat back to the transmitter, often seconds afterward as an echo. Echoes in radio are not uncommon. The ionosphere loves doing things like that, but a delay of seconds raises eyebrows. Does something repeat or reflect our signals back to us occasionally? But setting that aside, astronomers looking for transients in photographic plates and then have it result in a detection is in itself astonishing. They simply should not be there. And in 1950, no one on Earth was anywhere close to the capability of putting a satellite in orbit. And it's not just one candidate, but 3 that really do appear to line up in a non-random way, and not as a result of a defect in the plate, though this still needs to be confirmed. Whatever these objects were is a complete unknown. So the question is open. Were we being watched?
You have fallen into Event Horizon with John Michael Gaudier.
Beatriz Villarroel, welcome back to the program.
Thank you.
Now, Beatriz, you have a recent paper out, another in a series on transient phenomena in photographic plates. And this particular one is of particular interest because these are plates that predate the space age and look for, you were looking for objects that transiently appear that shouldn't have been present because nothing should have been in geosynchronous orbit around Earth. Now, could you give us an overview of that paper and what you found?
So there's a background to this paper, and that is that in last year, in 2021, VASCO published a paper where we found 9 star-like objects appearing and disappearing within half an hour. So like multiple transients in an image. So this image was very confusing because there is nothing that astrophysically should permit this to happen. So we did then a lot of tests. We ruled out a lot of explanations. We couldn't rule out absolutely every explanation, but all the astrophysical explanations were gone. And we were thinking maybe there is some type of contamination that produces star-like objects. However, we are not aware of any such contamination. It was one hypothesis, and the second hypothesis is that maybe there is some new kind of phenomenon that we discovered. And one of these maybe could be related to that you have reflections of highly reflective and flat objects in high altitude around the Earth. Because today we know that if you have a lot of space debris, you can get fast glints, something that looks like a transient in an image. So in a modern survey, it wouldn't be anything weird to see multiple transients. However, our image was from 1950, like 7 years before Sputnik 1. So that was the first paper. And then, so in order to test this hypothesis, we wrote a new paper where we did some statistical analysis of how can you actually test for this hypothesis. And that is by looking for not only multiple transients in an image, but those that fall on a line or happen within a narrow stripe to show that they are not random in an image. Let's say if you find 4 lying on a line or 5 lying on a line, and you need at least 4 for it to be very unlikely. So we actually carried out this test. It was a fast test for us to do since we have the VASCO project where we look for transients. And we found some interesting examples which are not, let's say, we cannot confirm their authenticity. Maybe there is still some type of randomness and some highly unlikely alignments that we simply got by chance, or maybe they are actually real. And well, that is what this paper is about, is that we found some candidates that we didn't expect to find, at the same time as they are not that strong that you just by statistics can say, yeah, this is real. They are in this kind of gray zone area where you still need to follow up on them.
Now, how do you follow up? What's the plan to check the plates? For example, if there's some sort of debris on the plate or whatever, what is the next step in determining whether these things are really there or not?
So far, we have not been lucky when it comes to direct access to the plates, because there have been pandemic restrictions, and also these plates, photographic plates, are so valuable that they don't give visitors direct access, which is something that I actually would like to have when I analyze them. I want to be present during the analysis. So,
now, is it possible that there are other plates that you could look at? For example, like the Vatican Observatory's plates that go back that far. I mean, can you sort of say, well, I don't have access to these plates, but maybe I can have access to another set of plates?
This is exactly what we are thinking about. To find a plate collection identified, some plate collection that is both digitized and where the original plates are accessible to the regular astronomer. And I think if we do that and can find a similar example in one of those, we could actually test it. So that's one of the ideas we are working with. Now,
what led you to the conclusion that what you were seeing in this set of plates was in geosynchronous orbit?
If you would have something in a low orbit, it's going to produce streaks on the plate rather than any, let's say, fast glints. But while this kind of very fast reflections are something typical for an object that is highly reflective and flat and is in a high altitude orbit, like geosynchronous orbit. And we simply thought that this could be something that one can look for, something that you will not confuse with an asteroid or anything else. So it's more that we have carried out a hypothesis test to look for these things rather than that we have found something and applied an interpretation of that.
Now, high albedo, meaning highly reflective. Now, this sort of stands in contrast to an asteroid. Now, to preface this, there was an incident, I think in the early 20th century, called the Great Meteor Procession, where multiple observers saw multiple meteors falling one after another in the atmosphere. And it was reported in newspapers, especially I think in Canada. And this suggested that there might have been a disintegrating asteroid that briefly was in Earth orbit or something of that nature. So it seems to me, though, that if you're looking at an asteroid, it would not be high albedo. It would be reddened, right? So
Exactly.
this looks exactly the opposite of what you would expect from a natural rock.
Exactly. So that's why we wrote this Acta Astronautica paper, like how to find something that you cannot confuse with anything natural, like these glints on a line, and so.
So how does this compare to something like a solar panel? I mean, if we're looking at a satellite today, that's the Starlink satellite or whatever, or something that has a large solar array, does the albedo sort of look similar to what we, our technology, our modern technology?
I actually don't know what is the albedo of a solar panel, but I know that many satellites are rotating pretty fast, and you would see a lot of glints, not only 4 or 5, but you would maybe see like a long, like a pearl band of glints. Or maybe you would even see like dashed lines from such a satellite. And while in the case of space debris, where you have maybe that it not only spins, it also has a precession, you could produce just a few glints in a line. So I would see such a difference. So if it's something, then I wouldn't expect it to be a satellite that is big and fastly spinning.
Now, how many objects did you see in the plate?
We found 83 candidates, with multiple glints. However, we cannot say if all of them are real or if a single one of them is real. But this 83 was the result of the automatized survey. However, we had extremely narrow constraints when we looked for them. So what we also plan to do is to relax these constraints. Then we will find many more candidates, and we have to follow up on these candidates with the citizen science project. So this will be implemented in the next step of the VASCO citizen science, to look for better candidates with these more relaxed constraints.
Now, what's that going to look like, a citizen science project? Now, I have taken part in these, of course. One was the Planet Hunters that discovered the weird star KIC 8462852, where you look at Kepler light curves. And now this is ongoing with TESS and many other areas. Now, what would it look like, a citizen science project? What would the person that taking part in it, what would they do to look for these transients?
So right now we have a citizen science project where the citizen can be looking at 2 images, one from 1950s and one that is modern from pan-stars, and can say if a star has vanished. So in the next edition, what I would like to do is to not ask the user to say if a star has vanished, but to look at the images where we know that stars have vanished due to these automated methods we also use, and mark how many and if they are aligned or if they are random. And in this way, we will be able to single out the most interesting aligned candidates, if they are 4 stars on a line or 5 stars or 15.
Now, Beatrice, how would you describe the shapes? In other words, what are these things, modeling them, what do they look like?
So these shapes were simulated by Hisham Gwergori, who was a PhD student at that time in Algeria. Now he's already a doctor. Congratulations, Hisham, by the way. And so he used simulation software called Blender to trying to see what kind of shapes could produce the glinting pattern that we see. Depending, of course, he introduced a spin, a precession also. And it turns out that there are 5 different shapes that he could identify. I'm sure maybe there are even more. One of them is like a double pyramid that is kind of dark, but has some type of reflective corner at the edge. Then you can also have a complex shape where most of the thing is kind of dark, but then you have this this highly reflective little plate in the middle of it, or sometimes maybe 2 even plates that are highly reflective in the middle or in the edge of the object. So there are different ways how you can produce this kind of glints. It's nothing specifically unique. And we can maybe even show for the interested ones some type of simulations on how these glints can be produced.
Now, in regards to these objects, so say you can confirm it by looking at other photographic plates. Is it possible to do a search today to see if they are still there?
Absolutely, and I think it would be even necessary to start doing this already now, because if you have the shapes and you have modern instrumentation, you will know what is the difference between the old instrumentation from 1950s that were used, where you had 15 minutes of exposures, and the modern instrumentation, where you have, let's say, much shorter exposure times. So you're going to see something else. You're not going to get exactly the same glinting pattern. You're not necessarily always going to get a PSF. Maybe you will see some extended dots now with a modern survey, where you have much better seeing. But you could, in principle, simulate what you expect to see in the modern surveys, and you could maybe look for them. And that's one of the things we hope to do.
Now, we look extensively at space debris. We have to, because there's so much debris from human spaceflight in orbit right now that it poses a danger to things like the International Space Station. Is it possible to look in that data set for evidence of these objects being there? Or are they simply too far out in geosynchronous orbit compared to what we look for in LEO?
I would be doing two different things if I had all the money, like all the possible financing for the project. The first thing would be to actually look among all these like glints produced by space debris today. And the second thing that I would like to do, I actually wrote an email to our company some days ago. Unfortunately, they did not reply to me. Imagine if you could go to this, if you could get to these geosynchronous orbits like some companies nowadays want to do. There are some space environment companies that want to clean up these orbits, for example, with a big fishing net. Now, if you would get all this debris, or not all this debris, but let's say a lot of debris, and take it down to Earth, how could you see the difference between our debris and something that has been there for, let's say, thousands of years? Well, the reflective material is going to be much less reflective, because you have radiation damage and you have also a lot of micrometeorites holes if you have something that has been there for 1,000 years or even just 200 years. It will have much more of micrometeorite holes. So you could possibly even identify the alien object or a non-human object by looking at a number of these micrometeorite holes. And that's one of the things that I would find very exciting to do. Sadly, the company didn't reply to me when I proposed it.
Now, an alien origin for these objects, to postulate that maybe there is a von Neumann probe or something of that nature that's 3D printing out, probes to look at Earth and study our progress, perhaps. Now, is geosynchronous orbit the ideal place that you would put such a thing if you were, doing a surveillance operation on the human species?
Well, we are putting things there ourselves all the time. So if I would be an alien, I'd put it there.
Now, and obviously the advantage of that is a global view. Now, can you look for objects that aren't in geosynchronous orbit in these plates, meaning stuff that's gonna smear, in much lower orbit, because we use that obviously very extensively as well. So could you do a search, perhaps using citizen science, if you could get access to the digitized plates for lower objects?
Absolutely, and we want to do it as well. It just needs slight reprogramming, because now we wouldn't be looking for point sources, we would be looking for these streaks. So it's a little bit more work, but we want to do it. And I am especially interested in looking for things that would have so-called dashed lines. That would be maybe on lower orbit, but also rotating, so that you not always have the reflective surface in one direction.
Now, effects of the sun. You can have a situation where radiation pressure from the sun can move an object. Can you account for that with these geosynchronous ones, or is the effect just not there in that orbit? In other words, can you
I wouldn't even try
look for
that.
movement? Really?
I wouldn't bother about that at this point. I think one needs to have much more material and better data than what we're going to get.
Now, is there a possibility, an analog of photographic plates in radio astronomy, in early radio astronomy, that might, pick up a signal or something from such a probe?
I actually do not know the answer to that question. I've been wondering a lot about when were the first radio survey done, and I still haven't figured it out. I didn't check it up, but it would certainly be interesting.
It would be interesting, and one of the earliest ones, comprehensive ones that I know was done by the Big Ear, which is the same radio telescope that picked up the WOW signal in the 1960s, I think the late 1960s. And I don't know of any comprehensive radio work before that, other than maybe, I don't know, Penzias and Wilson or something like that, but that was accidental.
But maybe one should do a similar VASCO thing to take the first radio sky thing and look for all the sources that have vanished today.
Yeah, that would be interesting. If the data exists, I don't know, because radio astronomy obviously isn't as comprehensive and early as the photographic plates are. Now, what other photographic plate sets could you target to try to look for other transients? I know the Vatican has some, but there are also, I believe Harvard has plates and things like that go back to the 1890s. And if you were to find something from the 1890s, then it certainly wasn't human, right?
I'd love to use the Harvard plates, but it still remains to be seen whether we will ever get access to them. So maybe there are other alternatives. I think there are also, like beyond the Vatican Observatory, there are also some plates from Crimean Observatory. Now I don't know how easy it might be to get access to those places given the political situation, but we have very good collaborators in Ukraine that might be able to help out here.
Now, in regards to looking at the plates themselves and contamination, what can happen to an old photographic plate that might mimic this effect?
If to be honest, I don't know of any direct things that can happen to an old photographic plate that produce contamination that looks identical to stars and has star-like profiles with different intensities, having matching full width half maximas as the real stars. I don't know what kind of contamination that could produce that. However, it is possible that maybe radioactive fallout could produce some type of these stars. However, there is one little thing related to this, and that is that we actually looked at the plates that we had from 1950 and checked if there were any atomic bomb tests nearby, and there were no registered official atomic bomb tests that year. So I don't know if that is a reasonable hypothesis or not, but that was the only thing we kind of possibly could suggest. Maybe there are some other processes during the plate production or so that could produce some type of point-like sources. And even if you produce them, the question is whether these sources would all have perfect profiles in one and the same image, or if it's extremely unlikely that you would have 4 or 5 or 10 of them that all would have perfect star-like profiles in the same image. I don't know. This is the thing I'm mostly confused by.
So, nuclear testing, that seems to stretch. That a nuclear test would create this profile of anomalies within a plate. I mean, it just doesn't seem. There's
a paper by someone called, I forgot his first name, but it's a Webb, in 1949, where an engineer saw some type of star-like objects on an X-ray plate. And that happened apparently during the Trinity test or so, but it was an X-ray film while we were having red emulsions. I don't know if the same thing would be seen on a red emulsion, I think it's much more unlikely.
It does seem that way. So where do you go from here? What is the plan to verify these and just sort of lay out what you intend to do to extend this research?
So the first thing I want to do is to search for better examples that are more statistically improbable, something that is so improbable that we don't even need to care about the original photographic plates, because we would say, oh, if this impossibly can be some plate defects by this absolutely perfect alignment that we find. So that's one of the things I want to do with the same plate material that we have, and also look for these dashed lines. That's the first step. The second step will be hoping that we at some point can get direct access to the original photographic plates, travel there and actually say whether they are real or not. And if we have a single of these candidates is real, then that's already fantastic. So these are the first steps we are going to do. And the third is to search for them in modern surveys. And this is a step I want to start very soon, because even if we can't get access to the old photographic plates, if we can find these objects with the predicted glinting patterns in the modern surveys, then we are doing quite well.
Now, extending that further, so say you look at the modern surveys and you confirm that these are there and are still there. What observations can you do? I mean, can you get some instrument time on something to take a look at them right now? In other words, confirm that if they're there, they're still there. What's that look like?
Well, I would hope to speak to some of the people who have doesn't the military have access to radars that follow or track objects at geosynchronous orbits? Because maybe one could speak to them. Maybe they would be interested to help. That's one of the possibilities. And maybe it would even be possible to, if you can localize them, maybe you can make or design a space mission to, or talk to people that in 10 or 20 years' time, someone would go there and pick them up.
Now, do you anticipate if you went to the military and asked for radar data, they would give it to you, or would they classify it and say, we can't tell you what the error bars are, and you run into problems there? Is that something that you expect?
I didn't think of that. I guess it depends on which country's military.
That's true. You could go perhaps to Sweden or,
Exactly.
I'm sure plenty of people are looking, I'm sure every country on earth is looking. So you don't really need the Russians or the Americans. You could ask, I don't know if there's plenty to ask.
We are in international collaboration. We try all countries we can.
Yeah, try every one of them. And eventually you get your data from, I don't know, France or something like that. This is definitely a puzzler. This is definitely something that just needs to be followed up on and seen, because if there were alien objects in orbit of Earth and we missed it, we've missed it this entire time, then perhaps we should reevaluate the idea of calling ourselves an advanced civilization. And all ears must be open. All eyes and all ears must be open with this stuff. We have to sort of drop the stigmas regarding the question of alien life, especially close alien life, and try to answer the question once and for all. Do you agree with that?
Absolutely. But there is also one more interpretation that could be, and that is that this has nothing to do with glints on geosynchronous orbits. It could also be that multiple transients are a very rare phenomena that happens on the sky for some other physical reason, and we just don't know what is this reason now. It could be a completely new phenomenon, and that has never been recorded. It would be equally cool, I would say.
It could be a scary one too, that Earth ensnares objects and holds them in a temporary orbit, and that one of them could fall on us, even if it's just an asteroid, a highly reflective metallic asteroid or something like that. It's something that we need to know about, right?
it could be something completely different than what we even imagine. It's just that the geosynchronous object explanation has a clear physical scenario that we can propose, while there might be something with new physics that we cannot right now imagine.
And this has happened before, because if you would have said time dilation exists in the universe, if you'd have told a scientist in 1880 that was the case, they would not have believed you.
Exactly. It happens all the time. We learn all the time. That's why this is so important to follow up on.
Thanks again for joining us, and I look forward to your next paper, and we'll do this again.
Perfect. Thanks a lot for inviting me.
It's not over yet. Join me as we continue to travel through the cosmos on a gentle wave into another episode of Event Horizon with your host, John Michael Godier.
Beatriz Villarroel, welcome back to the program.
Thank you.
Now, Beatriz, you specialize normally in things that disappear, where you see something in a sky survey or something like that, and then you don't. It just goes away. But in this case, in this particular paper, you detail something that appeared and then disappeared. Can you give us an overview of this photographic plate that you found where something appears and disappears?
So in this particular paper, we were focusing on one particular candidate that we found in the VASCO project. This candidate was found in our 2020 paper. And it turned out that for one of the transients, or objects that appeared and disappeared during a brief time, we saw that it wasn't alone. It had company of 8 more objects in the same field of view. And that was very suspicious to us. So we made a study on it, and we wrote a paper on it. And we published this paper, which everyone can read now and comment on and give their ideas on.
Now, with a single photographic plate like this, there is the possibility of a false positive, and that maybe contamination might have been in play, or maybe just bad photographic plate. So how do you go through eliminating the possibilities of contamination with a plate like this?
Well, we have done a lot of different tests. For example, we had to consider a lot of different types of possibilities that could give false positives. Let's say we were thinking about, could it be some ghost images? But ghost images are usually blurred out. We were thinking about scanning errors, where we had to compare different types of scans of the same plate. We were thinking, could it be some type of double exposures, where a plate has been exposed twice to the different part of the skies, and so on and so on. We tried to test for a lot of different possibilities of false positives. Some things we could rule out, other things we couldn't rule out, but they seemed rather unlikely. And for instance, contamination is something I think we should take as a first option, that somehow the plate has been contaminated or has some type of plate defects. The thing that is complicating it is that these stars, or what are star-like objects, have very star-like brightness profiles, all of them. You look there and they look really star-like, and that is what is so confusing about it. And then one needs to try to identify what type of contamination or defects would cause 8 or 9 star-like objects on the plate in the same region. Well, we already know by experience that it's usually the most boring explanation that explains an anomaly in the end. However, not always, but we should still try to focus on this first explanation to start with. And we've done a number of tests, and this is where we are right now.
So in other words, if someone sneezes on a photographic plate, it looks a certain way. It doesn't look like a point star-like object, right?
That's true. Actually, sneezes are usually a little bit more wobbly or elongated or come in different shapes, while these 9 things are very star-like in their brightness profiles. So that's why we wrote with an explanation that it could be some type of unknown contamination, because that means that it's something, it could be contamination very well. It's just that we haven't managed to pinpoint the source.
That's interesting, because that would, if you were able to identify it, if it's contamination, that's useful in and of itself, because when looking at old photographic plates, one should be aware that this type of contamination can occur. Has anybody seen it in any other plates? Anything quite like this, or is this just totally unique?
No, there are some more plates that have some type of dots, but not exactly the same way. We also list those examples in the paper, in the supplementary information, and those were less luminous, and some of them were related to scanning errors. So I think there are a few more plates that might have this kind of effects. So I don't know if it's the same type of effect or if it's slightly different, because we haven't investigated those plates equally carefully.
Now, if you look at one of these point-like sources, and the 9 of them, are they different brightnesses? I mean, are they all the same, or do they vary in magnitude?
They vary. They vary in intensity and still have star-like brightness profiles.
So what is the time frame here? When this telescope, which I think was Mount Palomar, this telescope re-imaged the same area shortly after and didn't see them a second time. What was the time interval?
So actually, there was an image taken on the blue emulsion 30 minutes earlier, where you cannot see the objects. Also, there was an image taken on the same type of emulsion, the red emulsion, 6 days later. And again, you can't see the objects. So it seems like they have appeared within these 30 minutes of like in between the blue and the red filter. Not the red filter, red emulsion, sorry.
Now, these plates, were you able to determine if they were all made at the same time? In other words, did the red plate from one day come from the same batch as the red plate from another day?
We don't know.
So there's sort of that. Now, what's the time frame? Now, people are going to say, well, maybe satellites or something like that. What's the time frame in which this survey was taken?
Well, this is actually something that, I mean, if you would have satellites on the sky and use this kind of instrumentation to look at the sky, you might see something like multiple transients. And it wouldn't be anything weird. However, the image is from 1950, so it would be much more exciting if that observation were true. Because in 1950, that's 7 years before Sputnik 1, and certainly one hadn't launched any satellite that high as to reach a geosynchronous orbit or wherever you could get this kind of effects.
So in 1950, well before, as you say, Sputnik or any satellites, we see 8 objects appear in one plate that weren't there before and aren't there since. Have you looked with more modern methods to see if these candidates are actually out there? I mean, do you have corresponding candidates for these stars that did that?
Well, we tried to look with the GTC, a very big telescope at Canary Islands. It's a 10.4 meter telescope. And we tried to get really deep images to see if there are some counterparts. Well, some of them might have counterparts, but statistically it could just be a background object. So it might be completely unrelated. So we haven't managed to confirm that it's that the object is related to our transient. We have also searched for them in all modern archives, and we haven't found anything. So, of course, if it would be something similar to a satellite glint, you're not going to see anything there, because that would be a very short thing of maybe half a second.
What about detections of something like a cosmic ray or something like that? Have you been able to eliminate those as potential candidates?
Well, cosmic rays are not a problem for photographic plates the same way as on a CCD. And for example, if these photographic plates would be sensitive to cosmic rays, they would be entirely full of them, because these plates have been probably in storage for maybe months or even years before they are used.
So now, what about something else that was going on at the time? Nuclear testing. Is it possible that some particle from a nuclear test, I mean, California is not that far from Nevada, so is that an option where maybe contamination from nuclear testing might have set off the plate?
We are speculating on that, actually. Like, one of our main hypotheses is that maybe that could be the case, because we have these kind of star-like brightness profiles. And there was some paper by Webb, I forgot the first name of the author, that showed that when the Trinity test was when it happened, it left rather star-like images on X-ray film. So maybe it could actually be the explanation. However, we're still wondering if it's not whether it's compatible with that we see more of these objects restricted field of view.
And it also has to be said that I think the majority of the fallout from the testing went the opposite direction. It went east as opposed to west, so you might not have the contamination there at Mount Palomar that you might, in, say, Illinois or something like that. So what would this imply? So is there a technosignature possibility here?
So let me answer this question. At this moment, with the observation that has been done, I wouldn't be interpreting any technosignature because it could be some type of contamination. However, there is a fantastic opportunity here that I never thought about until we got this paper and the results. And that is that there is actually one signature that one could search for in the POS1 plate that would not be confusable with contamination. And that is if you would find this kind of multiple glints along a line, because that would be something very, very typical of satellites or of space debris or whatever. And this is something that we can get as a side result of our general VASCO project, because we generally look for these transients. And now the only thing we need to do is to add a routine to look at, search for objects where you have many of them following a line. Because if you have that, you have something that would not be confusable with contamination, and you would have a very clear technosignature of something that is at geosynchronous orbits or higher, and that shouldn't be there in 1950. So it's a super easy way for us, given that we already have done most of this work, to test for artifacts SETI in the solar system and do this on a very short timescale of a few months.
So this would be something that gets into recent work and the Galileo project and all that, where maybe something is close and within the solar system, an artifact of some sort within the vicinity of Earth. So is that more likely? So say they're real, and there's something to it.
Yeah.
Is it more likely for them to be a close technosignature as opposed to something very, very far away?
I would say so, because that would be the easiest explanation would be that you have some type of pieces of metal, in orbit around Earth in a time when it shouldn't be there. Of course, it doesn't mean that it's ET. It could be something, it would be ET, of course, but it could also be something that has been there since, I don't know, maybe 500,000 years ago, and has stayed there since then. It doesn't mean that there's some UFO looking at us at the moment, but it still could be a very good technosignature. But it would have to be nearby.
But it would have to be nearby. But it also doesn't have to be active.
Exactly.
Right? So it could be some dead piece of something that just happened to show itself, or it could be active, I guess, right?
Well, it could even be something similar to ET's correspondence of Coca-Cola cans that it was left in orbit.
Which an alien Coca-Cola can would be about the most interesting thing we could ever find. Which makes you wonder if we launched a Pepsi bottle into space and an alien civilization found it, at some point in the future, it could be the most important thing they've ever found.
That's possible. Well, I think the most important thing really from the study was that it gave us this idea that we can so easily check for this. We can so easily get upper limits, because we are anyway looking for these transients now, and we have these automatized procedures going on, the citizen science project. And instead of only looking for vanishing stars, we can add this to our program. And I think that's the most important bit that came out of the paper, the idea.
Now, let's say you establish that stars do indeed appear and disappear, and this is new. And people are immediately going to say, well, before we go with the alien explanation, we need to look at what natural options there are. So do you have a profile of natural options for a disappearing or appearing star? It seems to me that stars are sort of, they don't work on those timescales, maybe with flares or something. Does that have legs? I mean, could we say we're seeing solar flares, brightenings?
Well, solar flares can happen within a few minutes. So if you see something just appearing and disappearing, you can have just a flaring object. And of course, not related to stars, but you can also have afterglows from gamma ray bursts or fast radio bursts. They can be seen in the optical and also be seen like a flash, very short one. The thing about the 9 simultaneous transients is that you have 9 of these things in a very small field of view that doesn't go with any natural explanation that we know of today.
Especially if they're distant, because this would be 9 separate stars, presumably separated by many light years, all doing the same thing at once, right?
Exactly. And if one actually looks at it with this 30 minutes of interval that we have, it's not going to work to place it far away from us. It has to be inside the solar system, whatever is happening.
Or or you get into simulation theory and there was a glitch in the simulation and the stars just simply did that. Do you put much credence in that sort of hypothesis?
Well, I would say it's a speculative idea as many others. Well, any idea that isn't this contamination idea that we're working with on first hand, that is going to be all equally speculative, I guess.
Now, there is an interesting developing, in other words, it's being built, that is probably going to shed a lot of light on your work as far as disappearing stars or appearing stars. The Vera Rubin Observatory, the LSST, what can you do with that kind of all-sky survey imaging?
I would say one can do almost anything if one has access to this wonderful instrumentation. And one of the things that one could do is that instead of doing this manual work we have been doing when looking for something that appears or vanishes, one can do this kind of routines that will automatically search for things that have vanished from the sky or appeared, like pipelines. And then one doesn't need to go back in time and compare catalogs, but you can actually, in the moment when something directly vanishes, you can get some type of alarm and you can directly point a telescope there and see what happened. So the opportunities are great with Vera Rubin telescope.
That's interesting. So you would be able to, so your computer program is looking through the data that it's collecting and it can see something, something changed, something disappeared, and alert you in enough time to post on the astronomer's telegram or something that, hey, everybody needs to look at this portion of the sky, this, these coordinates, and see if this thing is there, right?
Exactly. It's a fantastic improvement if one can use the Vera Rubin telescope.
I'm very excited for it because if you, it's almost a real-time camera, looking at the sky 24/7 or every day and a half or whatever it completes a survey. So this opens up it's the difference between a photographic plate and a video camera looking at the sky. And I think we're going to see amazing things, especially in regards to solar system objects moving. This might discover Planet 9, or it might map asteroids or identify any number of interstellar objects like Oumuamua or Borisov. And it's just going to be a constant flow of amazing things. I don't want to understate how excited I am for the Vera Rubin Observatory.
It's absolutely fantastic project and telescope. So I'm very much looking forward to all the science that is going to come out of it. So I share your excitement.
Now, you are also involved with the Galileo project. What brought you to join up and consider other possibilities within Artifact SETI?
Well, I was invited by Avi Loeb to join it, and I was super happy about it. And I still am super happy because this is such a super, super cool work. It's a pioneering project for when it comes to looking for UAPs or like UFOs and looking for solar system artifacts in a very serious way. I think it's a super cool project, simply so. That's why I accepted it. It took me about 2 minutes to think about it until I accepted it, and that's the 2 minutes it took to reply on the email to Avi when he wrote me.
This is a much more all-encompassing search for artifacts in the solar system than, as you said, the UAP. But this opens up ideas like searching collection points in the solar system, that Jupiter has been collecting interstellar objects for 4.5 billion years, and who knows what's there. So this seems to me to be a very efficient way of doing SETI, because you have just the entire product of an immense amount of time just sitting there. So it's almost like why didn't we think of that first? Because it seems to me to be easier to find that, or maybe find something, or eliminate the possibility as opposed to a transient radio signal, right?
Well, I think it also has the advantage of that people know what they are looking for, that this is going to be about focusing on anomalies on the sky and solar system SETI, or space archaeology, if you prefer to call it this way. And the difference is, like, if you have some other like conventional astronomy surveys, they are focusing on finding things that you already know, let's say supernova or M-dwarf flares or AGN. And then they maybe are filtering away a lot of these anomalies, while the Galileo project will be collecting all the anomalies instead in real time. So I think it's going to be fantastic. It can only lead to interesting science, in my opinion.
We could find an alien Coca-Cola can, and it would be just a completely new way of doing it, as opposed to radio telescopes.
Exactly.
So, Beatrice, what is the future for searching past sky surveys for transient events? What are you going to do next?
So the closest months, we're actually going to finalize the automated searches the Spanish Virtual Observatory has been conducting for the VASCO project. And we have been then automatically looking for transient in POS1 and POS2. And we have specifically been looking for vanishing star candidates. And this huge search in images probably is going to be done either by the end of this month or next month. So this is a very exciting thing. And also our citizen science project that has more than 120,000 classifications by now has made lots of progress. So we're going to investigate all the interesting candidates that appear there. And finally, we are going to execute this interesting study where we want to look for solar system artifacts by looking for if we find many transients along a line. This is the things that we're going to do the coming months.
Now, just to envision what that means, so transients along a line. So if you have a rotating object, a metal object that is glinting sunlight, it's going to, in these pre-space age plates, it's going to show blips, right? And they will move in a line, just to make that clear to the audience.
Yeah, sometimes they can leave these kind of traces that you find them along a line. Sometimes they don't, but sometimes they do.
And now doing that using more modern surveys would be a nightmare, because there's all kinds of spent rocket stages and all sorts of things that can glint sunlight. So we just have this little window where we can look at old plates before, pristine, before we filled low Earth orbit and everywhere else with objects.
Exactly, that was what is our thought. Because today there are maybe, millions of debris pieces that will be glinting. You can't do it today so easily. While in the POS1 catalog, if you use our image catalog, if you use it, and if you find something, you know already what you're looking at.
Now, the citizen science part, where can people find that and take part?
It's called ML Blink. So it's the web address reads like http://mlblink.org. I will send web address so that people can click on it directly.
There will be links in the description below. Well, thank you, Beatrice, and I will continue to read your papers, and I hope you find really interesting things. This idea of appearing and disappearing stars is novel, but really neat, and who knows what it might tell us about the universe.
Thank you so much.
Thanks for listening. I am futurist and science fiction
John.
author.
Wrong channel.
No, it's not. Thanks for listening. I am futurist and science fiction author John Michael Gautier, currently hosting Event Horizon and wondering where Anna actually came from. One day I had a tablet computer, the next I had a boss. Very disturbing, and be sure...
And that's enough of that.
YouTuber forever! Like, subscribe, and hit the bell!
Sell out.
What? Dr. Beatriz Villarroel, welcome to the program.
Thank you.
Now, Doctor, you work in an interesting area of science, a sort of unexplored area, I think, where you're looking for objects that change in this night sky, looking at old sky surveys, some quite old, actually, in the 1950s, as I recall, right?
Yes.
And you look for things that have changed, stars that might have disappeared in an interesting way. Tell us about that.
Well, we are looking for things that vanish primarily. And well, very often a lot of surveys are looking for things that appear on the sky while we are trying to find things that have vanished. And we try to look in the old surveys from 1950, so we try to have as a big time span as possible without losing too much depth.
Now you looked, your first paper I think was from 2016, right? On this, on the first group of surveys that you looked at it. Am I correct?
Yes, I was a PhD student when I did this paper.
And when you looked, you found one candidate that was interesting, and you've since looked at this candidate again. What do we know about this object, this star?
Well, when we found it in 2016, USNO claimed to have 2 observations of it. There were 2 images based on the POS-1 and the Palomar Sky Survey Cat 1 and 2. One image from the 50s, another from 30 years later or so. And in this new work that we have done, the new paper that was published some weeks ago or a month ago, we find that we show that these objects that seem to have vanished in the new surveys, like we previously couldn't find it anywhere again. If you use the Nordic optical telescope, you will actually find something one arc second away from these objects.
So there's something nearby where the original...
Well, there was so big errors also in the position of the previous coordinate measurement. It could just be just a error of the measurement itself. There's something very, very nearby that we think is the same thing. And if so, then it could be either that it's an object that was, let's say it could be a variable star in the 1950s that faded, but it can also be that some type of star that had some eruption or had a flare or something like that, or possibly some galaxy that had a supernova, or maybe it could be something else that had a very temporary and very short,
duration of whatever. Yeah.
Yes.
Now, you don't have any data just based on looking at these star surveys. You don't have any data on the distance. So this could be something that happened in a distant galaxy, as you mentioned, a supernova or something. Or it could be a variable star, right?
Exactly. It can be either of the cases. We don't know yet.
Do you have any characterization of this star at all? I mean, has there been anything other than just a point in the surveys? Have you done any observations or anything of it directly? We're
doing it right now, actually, following up.
So it's a work in progress, very much so, to see.
Exactly. It's a work in progress all the time.
Now, what did you do in this initial survey? What did you have to go through to find this thing in the first place? It seems to me that something that appears in the sky is one thing. Something that disappears is quite another. So what did you have to do to find this?
Do you mean the first survey in the 2016?
Yes, the 2016 survey, yes.
Okay, there we only looked for vanishing stars. And first there was curiosity driving the question, could it actually happen? And if it would, maybe it could be an ET indicator or indicator of something much cooler even than ET, some new physical phenomena, we were wondering. So we used like 1% of the US Naval Observatory catalog from the 1950s, which is about 10 million of objects. And we were checking for these 10 million of objects if any of them were missing in the Sloan Digital Sky Survey that is from about year 2000. And first, when one does this, you have what's called coordinate lists. And the coordinate lists usually yield a number of mismatches, if one calls it like that. And these mismatches one had to look through by eyes. And so it means that there were some 300,000 of images that we looked through quickly glanced through quickly glance through, it doesn't sound, how can we say? 300,000 is not a number one quickly glances through, but it was possible to look them through with the Sloan Digital Sky Survey through one of the functions, their Explorer. And we split it on 3 people.
So you did this by eye, 300,000 objects?
Yes, but there's list view or in the Sloan Digital Sky Survey in the Explorer where you can see 25 at the same time. And one could very quickly just look at this array and see if there was any black image or not. At least that's how we did it in 2016. And then we could very quickly go through pages, just searching for any images that were totally black. I think this method might have missed some possible candidates, maybe.
Now, that brings us to your more current paper of a few months ago where it looks like you found another 100 or something like that of candidates that might have disappeared. Tell us about that.
Well, in this paper, we don't do exactly the same thing. We have changed the routines. We have also relaxed the criteria. Because in the previous paper, we had as a criteria that whatever candidate we find must be confirmed in an image of both the first and the second epoch, to ensure that it's actually a star that vanishes. And that was something we tried in the first paper. In the second one, we are also trying to collect other type of transients that we may find. So what we have done now is that we expanded the work. We have used something like 60% of the USNO catalog, which is about 600 million objects. And then Johan Sodla, who was a master student, he has already finished his master thesis. He built a cross-match system for cross-matching the USNO catalog with the pan-stars. And this yielded 150,000 mismatches with the thresholds we were using. And out of these, we visually have examined very carefully 23,000 of images, looked through them. And what one actually finds is that there are about 100 of the images show some sort of transit, show an object or a point source. I would say more shows a point source that exists in the old surveys but don't exist in the new ones.
Now, what are the implications of this? Because this could discover previously unknown, maybe long-term variable stars or supernovas, but also there is a SETI aspect. Tell us about that. If all other natural explanations could be eliminated from any of these candidates, could this be taken as evidence of maybe some sort of activity by an alien civilization?
I would say one cannot take it as evidence. Even if all the other natural explanations are outruled, there is always some new physical phenomena to discover. So one can't take it as evidence of any technosignatures. However, if one is searching for certain specific technosignatures, let's say that one is looking for red interstellar communication lasers, then maybe one will expect to find brief red transients that are only viewed in one image or so. And then one would see something that looks similar to ours. However, there are a lot of other phenomena that also will look similar to our phenomena. So, and it's of course more likely that we have found some very natural phenomena.
So essentially, unexpected astrophysics, something that's completely consistent with what we know. We just haven't thought of it yet, and we might see a dimming star. Now, this has happened with the star KIC 8462842, where it was dimming in a very strange way, and even there was a long-term dimming trend as well with that. But then we find that it was dust in a very strange juxtaposition. This was something that no one had thought of before, essentially. So that's what a lot of these candidates are going to turn out to be, if anyone looks into them deeply, that they're going to be something where it's an unexpected astrophysical phenomenon. Am I characterizing that right?
Well, I think in this case, I think many of these objects might just be very expected and natural astrophysical phenomena, maybe not even anything unexpected, because there can be a lot of things that, for instance, there might be flares. Let's say if majority of our transients turn out to be the bright state of an M dwarf that flared, it can be some very common explanations among them.
In essence, you could find that it was a red dwarf, a young active red dwarf that just brightened briefly because it produced a super flare, so to speak, and that
exactly.
could explain. Yeah.
But then we would find some super flares, for sure. If it turns out to be that, then we will have some super flares recorded in our sample, which is also fun, I guess.
But what you're doing is you're seeing the flare, but you're actually seeing the calm down period after the flare. As you look through subsequent star surveys, you see the star getting dimmer and dimmer, and then you know that, well, we've captured a giant flare off of this star.
Well, but we haven't seen anything to be dimmer. We have only seen point sources in the 1950s, and then now we don't see anything there at all at the spot.
And there's nothing there. So whatever was producing this light is now below our threshold of detection then.
Yes.
Now, another thing that interests me with this is the idea of capturing supernovas in distant galaxies. And this would be, I mean, there are a lot of people that look for that sort of thing, but this would be an actual visual detection of past supernovas, maybe, in other galaxies. Can you tell us about that? Does this research give us an opportunity to discover, more about supernova activity and failed supernova activity?
Well, if we start with a normal supernova, then yes. What we would need to do is to do like follow-up observations and try to do much, much deeper photometry if we can see something that looks like a galaxy, or take a spectra of the object. Let's say if we would take the 2016 object and manage to get a spectra of it and find out that it's a galaxy and the redshift, maybe we would be able to discover supernova at much higher redshift, because most supernova discovered at quite low redshift, that's lower than 0.2. So this gives an opportunity to learn something about the supernova rate in the higher redshift universe. So that would be fun.
Now, we're in a very rare phenomenon, at least as far as anybody can tell at this point, if it actually happens, the failed supernova. Tell us about that.
Well, so the failed supernova, that means that some theoreticians predict that within a certain mass range, between 18 to 25 solar masses, stars may have a probability of, when they die, instead of going supernova, they actually collapse directly from being a star into a black hole. And what one would see is that a star has existed and then a star has vanished. So there is a nice paper by Adams et al. From 2016 that shows one of these possible candidates in a different galaxy. It's a candidate. I don't think this has been confirmed as a failed supernova yet, but it's an interesting candidate in a different galaxy where they have much higher star formation rate. However, in the Milky Way, we did some simulations, and it's simply too unlikely to find a failed supernova in the Milky Way. But because maybe one expects one failed supernova every few centuries or so, if they exist at all.
Now, this is a question of the mass of the star itself, right? Only a certain constrained size of star or mass of star can actually produce one of these things. Am I correct?
Mm-hmm. Yes.
Now, Doctor, what's in the future for searching these sky surveys? What other surveys are there that you could look at, or upcoming spacecraft, or even ground-based telescopes like the Large Synoptic Survey Telescope, maybe? What can you do with other stuff to look further into this idea of disappearing objects?
Well, I think the LSST gives plenty of opportunity, and also the ZTF, the Zwicky Transient Facility, give a lot of opportunity. I think to do any sort of transient astronomy, and I guess they have much better data with, let's say, with the CCDs. That's one of the ways how we could continue, provided that the Starlink satellites don't destroy the entire sky.
Well, that's another subject entirely, the Starlink satellites.
But if we are optimistic about that, then there's plenty of opportunity with the LSST and with the ZTF.
It's interesting because the instrumentation, the better our instruments get, the more real time, so to speak. It's not real time, but it's closer than what we used to be able to do with photographic plates. We can see things changing at a much faster rate than we used to. So if a star up and disappears, you've got a lot more to work with now, right?
It would be much easier. However, if a star only disappears once every 100 years in the Milky Way, then it's not going to help to have these new telescopes, because the probability will be too small to detect it anyway during a very, very short time window.
So an astronomer 1,000 years from now has a chance to find something, but maybe not so easy now.
Exactly. So simply, if a phenomenon is extremely rare, no matter how fantastic instrumentation we have and how often we do the observations, what matters is simply the time window.
Geologic time Geologic timescales are not friendly to the scientist. Now, Doctor, the one thing that people are going to want to know about is the technosignatures and the possibilities of SETI with this. Is there anything unambiguous that might be caught that you can think of in these surveys that would say that is not a phenomenon of astrophysics, that is an alien civilization? Is there anything, a dead ringer possibly here anywhere that you can think of?
Yes, I would say that. For instance, 5 stars vanishing at the same place.
Interesting.
Let's say in the same region. If you have, let's say, transients coming from, or if you have something that looks like a flare, let's say, for instance, a red dwarf flare, but you have several of them happening very next to each other and timed, like coordinated in time.
Interesting. So a pattern, essentially.
Yes.
A coordinated pattern of some sort of activity. Or, as you say, disappearing stars. So if you have 5 of them disappear, now, is there anything that would suggest that maybe they've done something very odd, like encased them in a Dyson sphere, if such things are even possible? And then you could look, I guess, in infrared and see if you see any emissions there and might be able to nail it down. Is that correct?
Well, that's one of the ways one can do it, yes. But I would always try to follow up with some very traditional SETI method, let's say trying to get looking with a radio telescope for typical radio signatures or something like that.
Laser or something like that might back up the...
Yes, I would try to look for something very, very... something that the SETI people have, a method that the SETI people have been using for decades before I would run and jump to any conclusion.
Yeah, it would seem to me that would be something that would take decades, because observation, before you could actually definitively say something, you would need a whole lot of observations and a whole lot of things that said this is not a phenomenon of nature. This is something else.
Yes, but I think transients that would be coordinated in space, that you have several of them happening at the same time, that would, for me, be quite a good SETI signature.
Now, they would need to be clustered, though, right around the same object, suggesting it's a civilization that's branching out, right, and moving to other stars nearby.
Exactly. And trying to communicate with us, maybe, or something that would be very, very clear and obvious.
That would be interesting, is if they decided to communicate visually by making things appear impossible astrophysically, therefore it must be an alien civilization, therefore they're saying hello. Just by messing around with stars. Interesting thought. All right, Doctor, it's been a pleasure talking to you, and I hope you'll come back and visit us again as you go through these surveys and maybe find more odd things.
Thank you very much. Thanks.
Thanks for watching Event Horizon. If you're new to our show, hit the subscribe button so you never miss an episode.